Let's quickly discuss utility shader. Utility shader is a very general purpose shader that can be used for creating passes, for use within compositing packages. It also can be used for debugging problematic areas and so many other things. So let's first of all create a utility shader. So Material Manager, create Arnold surface and utility shader, and apply it to the sphere, glass, and the abstract object, and run the IPR. Now open up the shader and see what we got. We have shade mode, which specifies how the surface should be shaded. We have a few shading mode, in.I, which shades the surface based on its normals and the incidence angle. We have Lambert, which uses a default Lambert shader to shade the surface. Flat mode uses a single luminance color. Then we have ambient occlusion. Plastic mode, which has both diffuse and specular components, and metal has only the specular component. We use shade mode just to specify how we want the surface to be shaded. The main attribute in the utility shader is the color mode, which allows you to use different modes like UV coordinates, normals, object ID, and so on. So I can change the color mode, for example, to normal. Now we can see surface normals in the scene. And now using the shade mode, I can change how the surface is shaded, but we still see the surface normals in these different shading modes. For the majority of times, you use utility shader to output different passes like normals to use inside your compositing app. In that case, the best shading mode would be flat. So let's change the shade mode to flat and take a quick look at some of the different color modes that we have. We have color, we have geometric normals, which is the shader normals in the world space. Unbumped normal is smooth unbumped normals in screen space. You have normals, which is the normal in world coordinates. Barycentric coordinates, which is the barycentric coordinates of the primitive. We have UV coordinates. Right now, our abstract object has no UV, as you can see from the tags list, and that's why it appears black. Let me quickly apply this grid shader to the object. Right click on the tag and choose generate UVW coordinates. And now if I delete this grid shader, we can see the UVW coordinates of this object too. Let's open up the utility shader again. We have U coordinates, V coordinates. There is surface derivative based on U and V coordinates. We have shading point relative to bounding box. We have primitive ID, which shows each poly or face with a different color in a triangulated mode. Uniform ID shows each poly or face with a different color in a quad mode. We have triangle wire, which renders a triangulated wireframe. Polygon wireframe renders a polygon wireframe as quads. You have object, which based on the name of the geometries assign a color to them. Edge length shows the edge length of the object as a heat map, and you can detect over tessellated areas using it. Float grid maps a color around a hash function based on the shading point. Reflective lines can be used to specify the contour lines of the object. Bad UVs shows the object with bad UVs in magenta. So if I delete one of these UVW tags, you can see it becomes magenta, and that means it has a bad UV. We have object ID, which assigns different colors to objects based on their ID. That can be very useful in compositing because you can have different mats for different objects. Let's say I wanted my clock and the sphere to have one common mat, so they should have one color. Let's add an Arnold parameters tag to the clock. And under the tag tab, you have user options. You can specify the object ID here. Let's type ID1. ID space 1 and control drag the same tag on our sphere. And as you can see from the IPR, because our clock and sphere has a similar ID, they have a similar color. And finally, we have bump difference and pixel error. So I invite you to go and read about these different color modes in the Arnold support page. But in the future lessons, we are going to be using the utility shader practically a few times and show how to render out different color modes as passes to be used in compositing. For now, change the color mode to shading point. Overlay mode allows you to overlay a wire or a wireframe on top of your shade and color modes. We have AO distance, which controls the maximum occlusion distance that is sampled. So if I use ambient occlusion shading mode and decrease this value, you should be able to see some changes. You can check out the AOV lessons in the rendering section to learn how we can export these color modes in the utility shader for compositing. So in this lesson, we covered utility shader briefly. See you in the next video.